Let me start with a question. Is AI really thinking? Imagine showing a computer a picture of a dog. You don't tell it that it's a dog. You don't manually describe its ears, its fur, its eyes, or its shape. And yet, the AI looks at the image and says, dog. How? Is the machine actually thinking? Is it understanding what it sees? Or is something completely different happening inside? To understand AI, we need to go beyond the impressive answers we see on the screen and look at what's happening underneath. Let's take that dog example. When you look at a dog, you recognize it almost instantly. Your brain doesn't stop and calculate every pixel, but a computer receives digital information. An image is represented as numbers. The AI processes those numbers through a trained model. The model has learned patterns from many examples. And when a new image arrives, it uses those learned patterns to make a prediction. So the process looks something like this. Image, information, patterns, model, prediction. But here's the interesting part. Nobody had to manually program every possible appearance of a dog. The machine learned useful patterns from examples. So, what exactly is artificial intelligence? At its simplest, AI is the field of creating computer systems that can perform tasks associated with forms of human intelligence. That can include perception, learning, recognizing patterns, reasoning, decision-making, and even generating new content. But there's an important distinction. AI doesn't need to behave exactly like a human. It doesn't need a biological brain. The goal is to create systems that can perform tasks that require some form of intelligent behavior. And that's why AI is much bigger than chatbots. Chatbots are just one small part of a much larger field. But that leads to a deeper question. What do we actually mean by intelligence? Intelligence isn't simply remembering information. We often associate intelligence with several abilities. The ability to learn, the ability to perceive the world, the ability to recognize patterns, the ability to solve problems, and the ability to make decisions. Another important capability is adaptation. Humans constantly adapt to new situations. AI systems can also adapt their behavior in certain ways, depending on how they are designed and trained. So when we say artificial intelligence, we're really talking about machines performing some of these intelligent capabilities, not necessarily reproducing the human mind itself. And this is one of the biggest misconceptions about AI. AI is not a human brain inside a computer. Humans learn through physical experience, memory, senses, emotions, biological processes, and years of interaction with the real world. AI systems work differently. They process data. They perform mathematical computations. They adjust parameters. And they learn statistical patterns. So a human and an AI system can sometimes produce a similar answer, while arriving at that answer through completely different processes. That's an important idea to remember. Intelligent behavior does not necessarily mean human-like intelligence. Now let's look at one of the biggest shifts in computer science. Traditional programming generally works like this. Rules plus data produce an output. A programmer defines the logic. The computer follows those instructions. But imagine trying to write rules for every possible dog. What if the dog is tiny? What if it's huge? What if it's sitting in darkness? What if it's facing away? What if it's wearing clothes? Suddenly, the number of rules becomes enormous. Machine learning takes a different approach. Instead of explicitly programming every rule, we provide examples. The system learns patterns from those examples. Data plus examples become a learned model. And this brings us to one of the most important ingredients in AI. Data. AI systems can learn from many different forms of information. Text, images, audio, video, numbers, sensor readings, documents, and much more. Think of data as the raw material. But there's an important warning here. More data doesn't automatically mean more intelligence. The quality of the data matters. The way the data is processed matters. And most importantly, the learning process matters. AI needs to discover useful patterns within the data. So what happens to all that data? This is where we meet another fundamental concept. The model. An AI model is a mathematical system that has learned useful patterns from data. During training, the model processes examples and adjusts its internal parameters. Imagine starting with a huge amount of information that looks almost chaotic. Through training, the model gradually captures relationships and patterns that are useful for its task. The result is a trained model. So remember this simple idea. Data provides the examples. Training changes the model. The trained model is used to make predictions or generate outputs. But how does the model actually learn? Imagine giving the model an input. It makes a prediction. Sometimes the prediction is wrong. We measure how wrong it is. That difference is the error. The training process then uses that error to adjust the model's parameters. And the model tries again. Prediction, error, adjustment, repeat. This can happen millions or even billions of times during training. Gradually, the model can become better at capturing the patterns required for its task. And that repeated improvement is one of the fundamental ideas behind machine learning. Now let's bring everything together. An image enters the system. At the lowest level, that image is numerical information. The model processes that information through multiple mathematical transformations. Different layers can learn different types of representations. Simple patterns can combine into more complex patterns. And eventually, those representations help the model make a prediction. It might output something like 97%, cat, 2%, other, 1%. But remember, the model isn't following one simple rule that says, for legs equals dog. It's using a large collection of learned parameters and patterns. Now let's organize the AI world. Artificial intelligence is the broadest concept. Inside AI, we have different approaches. One major approach is machine learning. Inside machine learning, we have deep learning, which uses neural networks with many layers. And one of the major modern applications built using these technologies is generative AI. So think of it as a family tree. AI, machine learning, deep learning, generative AI. These aren't four completely separate worlds. They're connected layers of a much larger technology ecosystem. Traditionally, many AI systems were built to classify or predict. Is this an image of a cat? Is this transaction suspicious? Will this customer buy something? Generative AI adds another capability. Creation. It can generate text, images, audio, video, and even computer code. Give a model a prompt, and instead of simply selecting an existing answer, it can generate new content. And this raises a fascinating question. How can a machine generate something new from patterns it learned from existing data? One of the most important technologies behind today's generative AI boom is the large language model, or simply LLM. An LLM is designed to work with language. During training, it processes enormous amounts of text and learns patterns in how language is used. When you give it a prompt, the model uses what it learned to generate a response. That's the basic idea behind many modern AI assistants. But there's much more beneath the surface. What exactly is a token? What are embeddings? How does attention work? And why did the transformer architecture change everything? Those questions deserve their own videos. Here's a question many people ask. AI has existed for decades. So why does it feel like AI suddenly exploded? Because several important things came together. First, more data. We now generate enormous amounts of digital information. Second, more computing power. Modern hardware allows us to perform massive amounts of computation. Third, better algorithms and architectures. Researchers discovered increasingly effective ways to train neural networks. And finally, scale. Models became dramatically larger. Data became larger. Training became larger. And when these factors came together, the capabilities of AI changed dramatically. With all this power, it's easy to think AI is almost magical. But it isn't. Underneath the impressive results are mathematics, algorithms, data, computing power, and training. And AI has real limitations. It can hallucinate information. It can produce biased results. It can misunderstand context. And it can give an answer that sounds extremely confident while being completely wrong. That's why understanding AI isn't just about learning what it can do. We also need to understand what it cannot reliably do. The more powerful the technology becomes, the more important that understanding becomes. If you remember only one thing from this entire video, Remember this flow. The real world produces information. That information becomes data. AI systems learn patterns from that data. Those learned patterns become part of a model. Then the model receives new input, and it produces an output. That output could be a prediction, a decision, or generated content. So the mental model is real world, data, learning, model, new input, output. Once you understand this flow, many AI concepts become much easier to understand. So, let's return to the question we started with. Is AI really thinking? AI can recognize images, generate language, create images, write code, solve certain problems, and interact with humans. But does that mean it has consciousness? Does it experience the world like we do? Does it understand things in the same way a human does? Those are much deeper questions. What we can say with confidence is this. AI can produce remarkably intelligent behavior through learned patterns, mathematical computation, and enormous amounts of training. And understanding how that works is only the beginning. Now you know what artificial intelligence is, but there's still a huge question left. How do machines actually learn? What happens during training? What are features? What are labels? What are parameters? What is loss? And how does a model know that its prediction is getting better? In the next video, we're going one level deeper. Machine learning. How machines learn patterns from data. And we'll build that understanding from the ground up. I'll see you in the next video.